Okay, in chapter 7, we're going to start using identities, and namely trig identities. And trig identities are just essentially formulas that are relating our trig values. So for this first section, you have this whole sheet that you were given. We're only going to use these first two rows today. Honestly, we won't do all of these this year. For example, we won't do too much of the sum to product to sum or product to sum to product identities. We won't do the power reducing too much, but we'll touch on most of the rest of these at some point over the next chapter. So in a trig identity, what we're trying to do is we're trying to do one of two things. We're trying to simplify an expression, which we'll kind of talk about the second part of this section, or in this first part of the section, we're trying to find exact values. For example, this first one says I'm given sine and I want cosecant. So my whole goal is to look on this identity sheet and see which identity relates sine and cosecant, which I think would be this one. So I know the sine equals 1 over cosecant, or I also have cosecant is 1 over sine. Doesn't matter, these are really the same thing written two ways, but I think the easier way is to use the second one because I am essentially trying to find cosecant. So cosecant is just 1 over sine, but I know sine is negative square root of 3 over 7. So it's 1 over negative square root of 3 over 7, which I can, if I have 1 over a number, I keep change flip, so it's going to be 1 times 7 over negative square root of 3. So we get negative 7 over square root of 3, or negative 7 square root of 3 over 3. Now this should look really familiar because essentially for cosecant, we know cosecant is just the flip of sine. So really 1 over any value, these all identities, these just flip the values. So to find cosecant, I flip sine, secant, I flip cosine, tangent, I flip cotangent, and vice versa. So those are called reciprocal identities, and you're just flipping like we always have. Now if I have sine and I want secant, I can't use this identity because those are not reciprocals of one another. It could be negative. Now another kind of very popular identity is the quotient identities. We have two quotient identities. Tangent is sine over cosine, cotangent is cosine over sine. And these both are related to the unit circle with y over x and x over y. So in this problem, we have tangent and we have cosine, but we want sine. So if I look at this identity, tangent equals sine divided by cosine. I know two of these values and I'm missing one. So the tangent is minus 1/3. I don't know the sine, so I'll just kind of leave that there. But the cosine is negative radical 5 over 3. So we're just going to solve this like any other problem. We have some unknown variable, sine theta, and we have a number here and a number on bottom. So I will simply multiply both sides by negative 5 square root of 3. So these will cancel. So my sine will be by itself, and then I just multiply on the other side. Negative root 5 times negative 1 is positive root 5 over 9. So you're really just using these as formulas. You're plugging in numbers and you're trying to solve them. In this first part anyways. We can do some other things with them later on, but for this first thing, we're just going to try to find some values. The last set of identities we have here are Pythagorean identities. And these are really, really helpful. Sine squared theta plus cosine squared theta equals 1. Tangent squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. So we use these a lot. Now, in the initial notes video, you saw a proof of how these come about, but I'm just going to show you how to use them. So in this problem, I have sine theta equal negative 1/4, and cosine is positive. Find cosine and cotangent. So I want to find cosine and cotangent. We'll find cosine first. Now the problem with this is, and why I have this thing here, is if I go back to my ASTC, it says sine is negative. Well, sine is negative in these two quadrants, But I know cosine is positive, which means all my sines have to be in quadrant 4. This will be important because I know cosine is going to be some positive number. And I'll show you why that's important here in a second. So I have sine, I want cosine. I'm just going to use this initial Pythagorean identity. Sine squared plus cosine squared equals 1. Now sine is negative 1/4. So I can replace the whole sine theta with negative 1/4 and solve the problem like this. So negative 1/4 squared is 1/16 plus cosine squared theta equals 1. I'll subtract 1 from both sides, so cosine squared, 1 minus 1/16 is 15/16 because 1 whole is 16/16 obviously. And then I'll take the square root. Here's why the sign's important. When I take the square root, it could be positive. But the reason I'm picking it positive because it's in that 4th quadrant. So this is square root of 15 positive over 4. And again, it's just the square root of 16 is 4. Square root of 15 doesn't simplify. So there's my cosine. Now it also asked me to find cotangent, which is fine. Cotangent is cosine over sine. Well, if I have these values, I know cosine is radical 15 over 4, and sine is negative 1/4. So I can cross out the 4, so I get negative root 15 over negative 1, which is simply negative root 15. So we can use these identities to find these values. Sometimes it's almost easier to set up a triangle in a given quadrant, but these identities will typically always find you these values as well. So give these problems a try. If you have questions, obviously, let me know and we can certainly work on them together.